Okay, so let's get started. Question one on the 2016 National 5 paper. So it looks like we've got a question about vectors to start off with. So we're told what P is and we're told what Q is. And we're to find the resultant vector half P plus Q. Okay, well, when we add vectors, we just add the components linearly, if you want to call it that. So we'd add this line, then add this line together. Okay, so half P plus Q, you could rewrite that as a half times P, which is 4 minus 6, plus Q, which is minus 5 minus 1. Maybe the first thing we should do is half vector P. So that's going to be 2 and minus 3. Okay. Plus minus 5 minus 1. And then I'm just looking to add my top line and then add the bottom line. Okay. So 2 plus minus 5 is going to give me minus 3. And minus 3 minus 1 gives me minus 4. Okay. Let me just check the marking scheme. So you get a mark for working out half P, and then you get a mark for the final answer. All right. Not a lot to that question, but while we're on the subject of vectors, yeah, if we're adding vectors, we just do as we did there. We just add the components linearly. So top line, the bottom line, nothing fancy. If we multiply by scalar, then the whole vector gets multiplied. So the half in front of P here affected both the numbers. Okay, and if you think about what that means, if you think of P as a vector like this, a half P is really just taking us to this point. Okay, so instead of say going, well, what was P? We were going along. In fact, yes, so P was going along 4 and then down 6. Okay, that's P. What we're actually doing is halving it, so we're going along 2 and up 3. Okay, so it's just half of P. Okay, so that'd be a half P. That would be a half P. So the whole thing would be P. Right. So we multiply the whole vector. What's another interesting fact over here? And the favourite question that they've been asking in a lot of the other previous ones I've done has been the magnitude. Okay, so don't forget the magnitude is just the vector squared and then square rooted. So the magnitude of P, for example, would be 4 squared plus minus 6 squared, and that's the square root. And again, I always think about that. If we think of vector P again, so we're going along 4 and we're going down minus 6. I always think of the vector as this kind of line here, okay? And if you think of your Pythagoras, there's your right angle triangle, there's your hypotenuse, work that out, we'd be doing, sorry, that's plus 4. Sorry, I should have gone to the plus 4 should really, sorry about that, you know, just to be completely accurate, sorry, and full disclosure. In fact, no, that's right, yeah, sorry, 4 is going that way, yeah, sorry, 4 would be going, sorry, that is right, yeah. Sorry, 4 is going that way. That'd be a Cartesian, that'd be correct. So I would think of this as the kind of the product almost, okay? I'd think of this as the magnitude. And if you think of it as a right angle triangle, opposite the right angle is your hypotenuse. So 4 squared plus minus 6 squared square root. That's the way I like to remember it. That's what jumps to my mind when I think about the magnitude of a vector. Okay. So yeah, that's us going over the addition of vectors. Like we said, we just add the components linearly. And if it was Z, if there was another Z, if there was a third component, just do the exact same. And if we multiply the whole component. Okay, and we just talked a little bit about the magnitude as well. All right, so a nice easy question to get started, and we should find that. We should find that initially we're thinking this is dead easy, I can do this. The first few questions are quite straightforward. All right, fractions, get really good at your fractions. These always come up. So, okay, the first thing we're going to have to do with this fraction is, what do you think? And again, I like to sometimes give some pausing time. If you go through the videos, feel free to pause it at the beginning of a question, try and do it, or maybe go halfway, then unpause it and whatever. But yeah, if you want to bash at it before I go through it, okay? So what we've got here, we're going to have to multiply and we're going to have to add fractions. Okay, so we're going to be using 2 of our rules. So the only rule we're not using is dividing. Okay, so I'll just go over the division rule up here. Okay, so say we did 3 divided by 2/7. Alright, we're going to use what I like to call KFC. Alright, so we're going to use keep, flip, and change. I always do that, I always write 2 C's for change. That's why I do it. Keep, flip, change. Alright, so we keep this the same, 1/3. We flip this term to give us 7/2, and then we change the sign to multiply. Okay, so that's the only thing we're not doing in this question is dividing. So I just thought it was worth going over it. Okay. So multiplying we are doing in this question, and I'm just going to go over this here. If we multiply these two fractions, we're doing 1 times 7, which is 7, divided by 3 times 2, which is 6. Okay, and we could rewrite that as 1 and a 6. Okay, because there are 6 sixths in a whole. Okay, and again, if you think about, I'm sure some people, feel free to skip through some bits if you think, oh, this is dead easy, but there are 6 sixths in a whole. Okay, if you imagine, you know, something like a pizza, yeah, 1, 2, 3, 4, 5, 6. Okay, so 7 6 the same. Well, there's 6 6, and I've got another 6 just over here, not part of a pizza. All right, in the same way that you could have, 7 7s, 8 8s, 9 9s are in a whole. Okay, so that's just gone over the stuff we don't need for this question. The other rule that we need to know how to do is add. So if we're adding a fraction like this, okay, so we've got the same denominator, right? It's dead easy. We just add the top and we keep the bottom the same. So 1/3 plus 1/3, 2/3. And again, you could visually think on that, couldn't you? All right, if you've got a pizza, and I'm really not hungry, I just think pizzas are the best way to describe fractions. Say we've got, that's, that's the worst drawing of a third. Say we've got, that's also quite rubbish. So we've got 3/3, okay? If we've got 1/3, yeah, as shown here, plus another third, then I've obviously got 2/3, okay? The big mistake people make is when they come to add fractions, is they say, well, 1/3 plus 1/3 plus 1/3 is equal to 2 sixths, because they add the top line and add the bottom line. If you think about it, that makes no sense, because 2 sixths simplified is 1/3, okay? Because I can divide the top and the bottom by 2. So I divide top and bottom by 2, I get a third, yeah? So how can it be that 1/3 plus 1/3 gives you 2 sixths? Doesn't make any sense, all right? So when you add fractions, you need a common denominator, but you wouldn't add the denominator. But like saying 1 car plus 1 car is 2 cars, okay? 1/3 plus 1/3 is 2/3. Okay? And that's why we need the common denominator, because right now a third plus 2/7 is like there's a third of a pizza. But let's just break it up again. So we've got a third of a pizza, and then we're trying to do 2/7. So it's like, well, 2/7 might be like, I don't know, like that maybe. So we're trying to add that on. So it's like, what have we got left? Well, it's kind of hard to tell, isn't it? So the rule for this is smile and cross. Okay, so let's do that bit first. So 1/3 plus 2/7. So we do our smile, so we multiply those two numbers. So that's going to give us 21. Okay, so we just times these two together. And then we're going to cross multiply as a cross. So we do 7 times 1 and 3 times 2. Okay, so there's a cross in there. Yeah, so 7 times 1 goes up here, and 3 times, so think of a wee arrow going that way. Okay, 7 times 1 goes up there. Yeah, and then 3 times 2 is down here, going to give us 6. Okay, now we've got common denominators, we can add them, so that's going to give us 13 over 21. Cool. Now we do the second part of the question where we times it by 3 over 4. Okay. Now at this point, you can simplify. Okay. Now when we did the division sign, right, you cannot simplify at this point. So say up here, say there was something that was divisible. So say we had a 6 in here, okay? See that was what we got back. Say we had a 6 and a 2, okay? In fact, you know what, I'll just do a whole other example up there. Alright. Work this out. So say we did a third divided by 6 over 2. You wouldn't simplify at this point, okay? You wouldn't say, like I'm going to say here, that, well, I've got a 21 and I've got a 3, and they both divide by 3. So I'm going to simplify that to 7 and 1. Okay, so they both divide by 3. The 4 and the 13 don't simplify. You don't do that for these questions, okay? That would change the question, okay? However, once you do your keep, flip, change, then you'd be in a position to simplify. Okay, now what I really should have done was made this question a bit more sensible. So say that was a 3 in there. Okay, then I'd be able to say, well, actually, look, they cancel out. Okay, so don't do the simplification for your division at this point. Only do it when you're coming to the multiplication part of the question. Okay. So yeah, that's just one little bit of advice, and then also here, that's me done the simplification, which is important for a non-calculator paper because it would just get quite hard otherwise. So 13 times 1 is going to give me 13, and then 17 times 4, that's 40, 58. Okay. So then I'm thinking to myself, is there any way that I can simplify that? Well, this makes me think of divisibility rules. Okay, so if it's an even number, it will divide by 2. So this bottom one will divide by 2, definitely. Um, top one won't. And then I'm thinking, well, maybe what would 58 divide by? Now, 8 and 5 added together. Okay, so 8 plus 5 gives me 13. So that's not really helping. So the other divisibility rule I always look for is the number divisible by 3. So 111 is divisible by 3 because 1 plus 1 plus 1 is 3, and 3 is divisible by 3. Okay, 222 is divisible by 3 because 2 plus 2 plus 2 is 6, and 6 is divisible by 3. Okay, etc., etc. 126 is divisible by 3. Okay, so some of them are more obvious than others, some aren't, right? But if the sum of the number is divisible by 3, then the number is divisible by 3. So it doesn't look like they're divisible by 3, and 13 is prime, so it looks like, yeah, this is as far as we can go. Okay, so marks for this one. You're getting a mark for the common denominator, so you're getting a mark here, and then you're getting a mark for doing your multiplication, and then a kind of final answer. So I think the simplification they were looking for was at this point, okay? So because we simplified here, we were good. If we didn't do that, we'd have to have divided through by 3. Okay, but we did that early on. Okay, so that's quite a straightforward start to the proceedings, I think. Vector question was slightly different from other vector questions, and usually they're asking about magnitudes, and that's been quite common in the last few papers. But I think the addition one is pretty straightforward. And then fractions, smiling across when you're adding them together, so we can get that common denominator, so we can add kind of like for like. Multiplication, we just multiply the top, multiply the bottom. The only trick is just looking for these simplifications. And for the division, KFC, okay, keep, flip, change. Okay, so you keep that one, flip this one, and then change the divide to multiply. And then you just do multiplication as normal. Okay, good stuff.